Hello and welcome to my YouTube channel, The Intersection. In this video, we will talk about selection sorting. So selection sorting by definition is a simple comparison-based sorting algorithm. And the way it works, array is divided into two parts, a sorted subarray and unsorted subarray. At the start, the sorted array has no elements, where the unsorted subarray has all the elements. The sorted subarray is empty, where the unsorted subarray has all the remaining elements. So let's look at the array that I have drawn here for you. And as you can see at the beginning, at the start, the sorted subarray is empty, and the unsorted subarray is the whole thing. So if you want to imagine the sorted subarray is right here at the beginning. So now the first iteration starts. So when at the 75, we'll go from the 75, scan 65, and then keep scanning 100, keep scanning the 35, keep scanning the 22, keep scanning the 88, keep scanning the 16, and then scan 44. Now we know the 16 is the lowest if we're doing ascending, and this, so now 75 will replace the 16. So we're going to go to the 16 and replace it with the 75, and then the 75 with the 16. Now the sorted subarray here to the left. Then we do the same thing for the next element. 65, we scan 65, we scan 100, we scan 35, and then the 22 and the 88 and the 44, and we know the 22 is the smallest. So then we replace the 22 by 65, and then the 65 by the 22. So now we know the sorted array is up to this here. So you always, the sorted array, the sorted subarray is always to the left, where the remaining unsorted subarray to the right. So if I want to know how many times this will run, you can see that the first time, this is 1, 2, 3, 4, 5, 6, 7, 8. So the first time the outer loop runs once, and then the inner loop runs 7 times. So the first time is 7 times plus 6 plus 5 plus 4 plus until you finish the whole thing. So as you can see, it will take a lot of iterations for this small array number of elements, and as the array grows, then that would become not very efficient loop. So here's the pseudocode for the selection sort, and you can see the name of the function here, selection sort, and it accepts the array. And the outer loop, its main objective is to iterate through the array, iterating through the whole array, through the whole array, where the inner loop finding the minimum, the value inside the minimum index. So the first one, the outer array, goes through the array at position 0, where then it will be compared with the first element. Now, the second element. So the first element at 0, the second element at 0 plus 1, because that's the inner loop. So that's this position. So it will compare the value of this element at index 0 with this and this and this until it finds the smallest value of the array. So the second loop finds the minimum index in the ascending order or the maximum, and then the outer loop loops through the whole array. The swapping after the inner loop, finding the smallest elements and the unsorted portion of the array, So what is the efficiency expressed in the worst case scenario? And the worst case scenario, as we mentioned in our class, it's what's known as the big O notation. So let's look at this, the outer loop, ON, and the min index, a constant, so that's 1. And the inner loop is ON minus I. So the first one is ON, the second one is ON minus 1, ON minus, and so on and so forth. And the F here is O1. Same as the value here, O1. And the min index, of course, is O1. And the swapping is also O1. So you can guess it. You can now multiply the numbers and take the highest order. So we can see this, the efficiency of this scenario, the worst case scenario, is ON squared. Now let's see this in action. I have created a class called a selection class. In this class, there are two methods. And the first method is to use a for loop in the outer and the inner. So I have just to demo using for loop, just to demo for you that using for loop and the and also the inner loop. So there it's nested loop. So to demo the nested loops, as you can see, on the first loop, this is the outer loop. So in the outer loop, we'll go through the index 0, okay, and all the way to length minus 1. And on the inner loop, we will compare the index 0 with index 1. And so to see if this is smaller or larger, but you scan the whole array. You scan the whole array, and then after you scan the whole array, you determine which one is the lowest value, because in the ascending order, I'm doing it in the ascending order. If this is the lowest value at index 1, for example, then we will replace what's inside the indexed 0 with the what's inside the value. Change places. That's what it is. And then you go through the whole array. And of course, this is ON, as we determined, ON squared. Not very efficient. And then you swap. And now we're gonna go show you the for loop. Here's the for loop, and in the for loop, the outer for is replaced by a while. Here's the while, and it's gonna go through the I equal 0, or the index 0. Once it goes through the index 0, then all the way through with the inner loop, and does the exchange and the swapping. So that's the logic for the while loop. Now the bottom one I used, in the bottom method, I use the enhanced for loop that's in Java, and that's just to display the values. And now I created the driver for this class, and that's the driver for the class, and I have created two integer values arrays, and we can now demo and see if we are getting the good result. And of course we are. Here's the original loop, and here's the sorted, and here is the using while, the original loop, and here is the sorted loop. Just so I close this so you can see the whole thing, and you can freeze or stop the video and look at the code. At the end of this video, I'm going to talk about using Java generics, and I'm going to use Java generics to demo the same example for you, which is selection sorting. And there are so many benefits to Java generics. What comes to my mind are two: the safety, the type safety, and the code reusability. And the type safety in generic enforces enforces at compile time the safety and catching any related errors at early development in your process. And the code reusability is, as the name implies, is with generics. You can use the same sorting algorithm and apply it to, say, in our case, arrays of integers or strings. Without any further ado, let me show you the code that I have created using generics. You notice you notice at the beginning here I added this T here because I'm having the same classes on the same package, so I have to use different names. That's why I created selection T, and the T also indicates that they are generic type T and extends comparable. The comparable interface here is an interface that is built in with Java, provides a single sorting sequence, and everything is almost the same except changing the generic type on our steps. So this is the for loop, and this is the while loop, and this is the demo or display using enhanced for. Here is the driver for the generic class. I have two arrays, one of an integer value and the second one with the string values, and it will both run the same way. So let's run it and see. And here it is. The values, here's the first array sorted, that's the numeric array, and here is the string array sorted. I'm going to place this in the portal for you, and then you can download the code. Thank you and have a beautiful day. Bye-bye now.